Hello all, welcome back. In the previous tutorial, we have seen how to develop your own custom IP cores. So in this tutorial, I'm going to talk about developing driver software for your custom IP cores. Okay, so you might have heard the term drivers. When you install a new hardware in your computer, usually you have to install a corresponding driver also. So if we look at the computer architecture, and if I represent it as a layered architecture, at the lowest level we have the hardware sitting, and the layer which is closest to hardware, we call it the drivers, and on top of drivers sits our operating system, and on top of OS sits our application software. Again, here the main idea is abstraction. That means your operating system, it doesn't have to know about all the details about the hardware. Instead, your hardware comes with a special software called driver, and the driver will be knowing about all the intricacies of your hardware. So whenever the operating system has to communicate with your hardware, it actually communicates with the driver, and the driver effectively communicates with the hardware. Okay, so the idea is again to have some level of abstraction. Now, when we talk about our custom IP core, we have seen these IP cores are implemented using registers inside the IP core. Now, what our driver does is it will give you, or it will give the user who is going to use your IP core with the basic access to your IP core. So your driver should be providing basic read and write operations to your IP core. Again, why we are doing it? We want to make the life of programmers easier. We don't want them to go and check the user manual each time, like how to read from this IP, which register should be checked, what are the registers, what their addresses are. So all this information we want to abstract away and give them a simple interface to your IP. So basically, all these IP drivers, they have at least three functions. One function will be basically to initialize the IP, another function for writing something to the IP, another one to read from IP. These are the three basic operations the driver will be providing. In addition to that, depending upon the type of IP, there will be other functionalities available. Like if you are using an IP for image processing, there could be a dedicated function for sending images to your IP. There could be a function to read image from your IP. There could be a function to do a particular image processing using your IP, so on and so forth. But basically, at least there should be three functions. One is initialization, one is writing to IP, and one is reading to IP. So this software we usually distribute as part of your IP core. So you will distribute your Verilog code, the component.xml file, and the C code which corresponds to the driver for your IP. Now, if you check our IP core folder, this one, not this one, IP core one. So it was inside IP core GPIO control, GPIO. You will see a folder called drivers. Inside that source folder, Xilinx, they already provide a template for the driver for this GPIO. So whenever you create a custom IP using Vivado, it will give a template for driver, the basic operations, basic read and write operation. But we want to improve it, and that's what we are going to see today. So in order to do it, usually you will make a custom IP and create a simple system using that custom IP, which we have already done. So this is our custom IP GPIO controller, and we have already created a simple system using this IP. So next we will export this, and and we will launch SDK. Okay, as before what we were doing. Okay, now we can go to File, New Application Project, and let's call it Test GPIO or something. Standalone. Make sure the hardware platform is not Z, but this one, whichever you exported. Next, and choose empty application. Finish. Now there is a standard way of writing drivers. You usually have two files for your driver. One header file, which will have a model for your hardware and the declaration of all the functions, and a .c file, a C source file, which will have definition for all your source file. Okay, so that's how we usually develop it. So first let me write that header file. So I'll go to source and choose new header file, and let me call it GPIO control.h. Okay, so this is how header file template looks like. You will see a hash if and if and hash def and hash and if. So this you should go and check. This is a technique used in C and C++ to avoid something called circular reference. What it is, please go ahead and check. Okay, so first thing that I'm going to write is a model for my hardware. So in your drivers, when you write it in C, your hardware will be represented as a structure. So the idea of structure is similar to the idea of classes in C++. The only difference is in classes you can abstract both data and methods, but when you're using structures you can encapsulate. Okay, and you can have only multiple data inside it. You cannot have functions encapsulated inside a structure. But if you are using C++, you will represent your hardware as a class, so you will be encapsulating both the data as well as the methods associated with your hardware there. Now we are using C, so we don't have classes here. What we have is structures. So this is the syntax for structure. Struct keyword, name of the structure, let me call it GPIO control itself, and curly bracket and close curly bracket. This is the syntax for structure. Now later, the same way you generate objects from classes, you will have to create variables from this structure, and while doing that you will have to declare the data type as struct GPIO control, then followed by the name of the variable. Now it becomes inconvenient to keep on typing struct GPIO control. So if I use something called this type def struct GPIO control, and before this semicolon again GPIO control, I can create my variable simply by calling GPIO control. Okay, so type def, again you can go ahead and check if you haven't seen it before in C or C++. What is the use of type def? It's a technique for aliasing. Okay, so here I am going to represent my hardware. So basically you will write all the important information about your hardware inside this structure. Again, that depends upon what kind of IP cores we have. Personally, we have a very simple IP core, and almost every IP core will have one important information, which is its base address. So that I am going to declare here, base address, and its type is an unsigned int. So you can either type unsigned int base address, or more safer one is U32, unsigned int 32-bit base address. Now this data type U32 is declared inside a header file called sil type. So let's include it, hash include sil types.h, and this one. Okay, so I don't know if there is any other important information for my IP core. If you prefer, you can store the different register addresses also here, but depends. In our case, I don't think we need it. Now after this, you have to write the different functions for your IP core. So one important function, as I mentioned before, is to initialize your IP core. So let me call it init GPIO. What this function does is it initializes. So usually in initialization, what happens is the base address of your IP will be initialized. Okay, your base address will be initialized with the actual base address of your IP. So this function usually takes two arguments. One will be a pointer to the structure which represents your IP core. So since it is a pointer, we will write like GPIO star, okay, my GPIO or something. So GPIO star is representing this is a pointer to a GPIO type data. Another one will be the base address will be coming. Okay, so I'll be writing it something like this. This is a pointer to the structure, base address equal to base address. So in classes also you have the same operator. If you are using a pointer to an object, you will use this one. If you are using an object directly, you will use a dot operator to access the data inside that. Okay, same concept here. Now this is a header file, so I'll keep only the declaration here, and the function definition I will move to a .c file that we can do later actually. Now let me write another function, write GPIO. So this function will be used for writing something to my GPIO. Again, he will take two arguments, the pointer to my GPIO, and let's call it data to be returned to the GPIO. Now I'm taking the data as 32-bit because all the registers inside my GPIO, they are 32-bit. Now if you remember, if you want to write something to my GPIO IP, you have to write to base address plus 0. Okay, so you have to write out 32. That is the function for writing anything to a peripheral. My GPIO base address plus 0. So basically my GPIO base address followed by write data. Same way for reading, read GPIO, it will be a pointer and it will return the data which is read from GPIO. Okay, so we will say, I can say return in 32, my GPIO base address will give you the base address, and the data from where, or the address from where you should read back is address 4, the second register. Okay, so the register addresses, they increment by 4 because each register is 32-bit, remember. But in your Verilog code, you saw the addresses are incrementing by 1 because internally these addresses are divided by 4 automatically. But again, from processor point of view, the addresses are incrementing by 4. So you need to write like this. My GPIO base address will return the base address plus 4. So if you do read from that, you will be getting the switch position if that register is connected to the switch. Okay, now I'm going to move this definition to a .c file. So I'll say new source file and GPIO control.c. remember the .h and .c file should have same name but different extensions, and here you will include the header file GPIO control.h, and you will add the definitions there. So I'm going to take all these definitions from here and I'm going to put them here, and I'm going to make them only declaration. This is the standard way of writing. In the header file you keep only declaration, and the definitions you keep in a .c file. Showing some errors. Undefined reference to main. Yeah, that is fine. We are yet to write what main is, and still there is a spelling mistake here, still in 32. And another thing is those functions are defined in still io.h, so I need to add that also here. Okay, so errors have gone away. Only error is undefined reference to main. We don't have a main in our project, so we'll add a main function. Okay, so here it is int, so let's return 0. Okay, so now let's write a main. The main will be basically used for testing whether our code is working or not. So I can say like test gpio.c file. So this is where I will write my main. So I will do hash include gpio control.h int main. So the first step is to create a variable from this structure. So we'll say gpio control my gpio. Okay, so gpio control is the data type, which is a structure. From that we are creating a variable called my gpio, and the first step is to initialize it. So we need to call this function init gpio, and we need to pass two arguments there. First one is a pointer to the gpio, so I will just write ampersand my gpio. Second one is the base address. So again, the base address is coming from xparameters.h header file, so we need to check that file, and this is the base address. Okay, so we did initialization. Now basically we can write the same code where your software reads from the slide switches and write it back to the LEDs in an infinite loop, the same one we did in lab. So we can write write gpio, and first argument is the pointer to gpio, comma second argument is data read from the LEDs, sorry, the slide switches. So read gpio, again that takes the address as the argument. Okay, so that's it. So this code will basically read from slide switches, okay, and write it back to the LED. And notice that the user, the application developer, whoever is writing this software, he doesn't have to know about any register detail because you have abstracted it, and the only information that he needs to know which are the functions for reading and writing. That's it. So I told him this is the function to read gpio, and he needs to pass a pointer, and write gpio for writing. That address information, base address plus 4 information, is abstracted from him. That is handled by my driver. So basically these .h and .c file together, they constitute the driver. And this one, if you test on hardware after generating this stream, it might be working. So what I'm going to do now is this .c and .h files, I want to distribute them also as a part of my IP core to the third party, to other people. So what you do is you will go to the .sdk folder and go to the source folder, and you will see the .c and .h files there. We will take it from there. Maybe even this test GPIO, this example file also you can include if you prefer, but we usually take only the driver files. Okay, I take them from there. I will go to the IP repo, GPIO controller, and put them in the source folder. So there are some driver files here provided by Xilinx. I don't want them. Keep the make file there, and I'm going to put this .c and .h files there, the updated driver. Okay, so now onwards, when you give your IP to other people, you will be giving this entire folder, this XML file, component.xml, the HDL files, the driver file, the GUI file, all these files actually. Now, the change in driver source code has to be updated in the component.xml file. So what you need is you need to open that Vivado project which was used for editing that IP. Remember? So that's why we kept that project here. This one, edit GPIO control. So open that. And open component.xml, and here you can already see a warning here under file group. If I click the warning here, he's saying he cannot find this file GPIO control.h. This file was there before, the one from Xilinx which I just deleted. Okay, and if I come here under software driver, if I expand, yeah, he's saying like he cannot find these three files because I already deleted them. So what you can do is you can right click and choose remove file, and you can add your own driver files now to this one. Okay, so choose OK. Now your files came here, the one we created, GPIO control.h and GPIO control.c. But still you can see some warning here, and the warning is basically saying for these two files, okay, the absolute file path is included. For example, you can see these three files are also there actually, tickle file and make file. And if you see the path to the file, you will see it's only written driver GPIO control source make file. So the path is with reference to your project, but here you can see the entire path is there, D Vivado project IP repo GPIO control. Now if you distribute your component.xml to other people, this will definitely cause problem, because they should have these files in this particular path, which may not be the case. So you need to change the position of these files with reference to the project. That means basically we need to store only driver GPIO control1 source GPIO control.h and .c. We don't want this D Vivado part, but unfortunately I cannot change it in this GUI here. I cannot change it here. There is no option to change it here. But if you remember, this information is actually coming from component.xml, which is a text file. So I can go here and open that component.xml file and modify it directly there. So D colon archive location. Okay, it's a big file actually. He cannot find that folder. Let's search for drivers GPIO. Oh, I think that information is not updated there yet. So it will be updated only if I go to review and package and choose repackage. Okay, now this information is updated here. Now I should be able to find it. Yeah, here you can see the entire path is here, dvivado project IP repo. So we delete it and only keep from driver onwards. Just keep driver GPIO and save it here, close it, and here close this and double click component.xml once again. And this time when he opens, if I go to file group and software driver, you will see like it starts only with driver and those warnings have gone. So again, let's repackage once again. Okay, and close it. Okay, so we changed the IP. That means if I come back to Vivado where I created the system, he's saying like IP catalog out of date. That means some IPs have changed. You need to click refresh and you need to click show IP status, and here he's showing like GPIO control has changed on the disk. So you need to choose upgrade selected. Okay, so he upgrades it to the newer version. Although the Veloc code didn't change, he detected the component.xml file has changed. That's why this warning came. Okay, you can generate everything once again. So what I'm going to do is I'm going to close this SDK project and I'm just deleting that SDK folder also. So that's my GPIO. There is this .sdk. I'm deleting it. And what I'll do is I will go here and again export hardware. Okay, and I'll say launch SDK. Okay, this is just to check whether my drivers are automatically exported to SDK, the updated one. Okay, so my original source code in SDK I have already deleted, but the driver source code I have associated them with my IP code. Now this time when SDK opens, you can see this folder here, drivers, and if you open it here, you can see GPIO control.c and GPIO control.h. They are already exported to SDK. So what I can do is I can just go here, new application project, and choose GPIO test, and next empty application, finish. And on the source I can say source file, and again test gpio.c, and I can just say hash include whatever the header file was, gpio control.h, gpio control.h, and int main. I can look at the header file and just say GPIO control my GPIO, and init GPIO ampersand my GPIO, and include X parameters. And pass the base address here, and while one, the same code that you wrote before. Okay, write GPIO ampersand my GPIO, read GPIO ampersand my GPIO. Now what I wanted to show you that when you distribute your IP to other people, they will have direct access to this driver. So the only information they want to check is what is the name of the structure to represent your hardware, what is the function for initialization, what is the function for write, what is the function for read, and they can directly write the application software. This is the application software, this is the driver software, and you have the standalone OS standing in between these two, and you have the low-level hardware here. Okay, so always remember, whenever you develop your IP core, it is your duty to develop the corresponding drivers also, and include that driver software in the IP folder and update it in component.xml so that that automatically gets distributed to the third party. Okay, that's all. Thank you.